They're faster than the blink of an eye. They can travel over a mile with deadly precision, and yet most people have no idea what actually happens inside a bullet when a gun is fired. From Hollywood slow-mo scenes to real-life applications in war and law enforcement, bullets are everywhere in our culture. But how does this tiny metal object cause so much force, speed, and impact? What chain reaction makes it explode from a barrel at supersonic speed? Today on Origin Stories, we're breaking down the explosive science, surprising history, and inner workings of modern ammunition. From the trigger pull to the target hit, this is what really happens inside a bullet. Let's start by clearing something up. When most people say bullet, they usually mean the entire cartridge, but technically the bullet is just the projectile, the tip that flies out of the barrel. The full cartridge consists of four main parts. 1. Bullet. The actual projectile. 2. Casing. The metal shell that holds everything together. 3. Gunpowder or propellant. The chemical energy source. 4. Primer. The tiny explosive cap at the base. Together, these components form one of the most efficient, compact mechanical systems ever invented. But the magic, or the violence, only starts when you fire it. Here's the moment of truth. When you pull the trigger, a firing pin strikes the primer at the base of the cartridge. The primer contains a shock-sensitive explosive, often lead stiphnate or a similar compound. That strike causes the primer to ignite, creating a small flame that travels into the casing and lights the gunpowder. And that's when the real action begins. The gunpowder rapidly combusts, turning into a high-pressure gas that expands in a fraction of a second. This expanding gas pushes on the back of the bullet with massive force, propelling it forward and out of the barrel, often at speeds over 1,000 feet per second. No batteries, no electronics, just chemistry, physics, and clever design. Once the bullet exits the barrel, it's not just a chunk of metal flying through the air. It's a precision-engineered missile. Inside the barrel, there are spiral grooves called rifling. These grooves spin the bullet, stabilizing it mid-flight, like how a quarterback spins a football. This rotation gives it accuracy and helps maintain trajectory over long distances. The shape of the bullet, its weight, the material it's made from, all these details affect its performance, from how fast it travels to how deeply it penetrates a target. And yes, some bullets are designed to expand or fragment on impact. These are called hollow points or soft point rounds, often used by law enforcement or hunters to maximize stopping power while minimizing overpenetration. Not all bullets are created equal. Let's break down some common types of ammunition and what they're used for. 1. Full metal jacket, FMJ. The most basic and widely used, a solid lead core encased in a harder metal like copper, designed to maintain shape and penetrate deeply, used in military and practice rounds. 2. Hollow point. These have a cavity at the tip, designed to expand on impact, more stopping power, less risk of exit wounds. Common in self-defense. 3. Armor piercing, made with a hardened steel or tungsten core, designed to go through metal plating or bulletproof vests. 4. Tracer rounds contain a small pyrotechnic charge at the base that lights up during flight, allowing shooters to see the path of the bullet. 5. Incendiary rounds ignite flammable targets on contact. Used in anti-material warfare, not for typical use. Each type is crafted for a specific purpose, and when used correctly, can be incredibly precise. When used irresponsibly, deadly. So, how much force are we talking about? A 9mm handgun bullet can hit with roughly 400 foot-pounds of energy. A rifle round, up to 3,000 foot-pounds. That's like getting hit by a sledgehammer, traveling at the speed of sound, and yet all of that is generated from a small chemical explosion that fits in a metal casing no bigger than your thumb. The efficiency is almost unsettling. It's a portable, single-use engine, burning fuel, generating pressure, and launching a precision tool downrange in a controlled explosion. Modern ammunition has come a long way. Early versions like musket balls were crude and inaccurate. You'd pack powder, stuff the ball, tamp it down, and hope for the best. Then came percussion caps, metal cartridges, and smokeless powder, turning slow reloads into rapid-fire capability. Today's bullets are the product of hundreds of years of innovation and are more powerful, accurate, and deadly than ever before. But with that advancement comes responsibility. In most countries, ammunition is tightly regulated. Owning or using it requires knowledge, training, and legal accountability. Because behind every bullet is not just a spark and a shell, but a serious consequence. So, to recap, A bullet works by using a chain reaction of ignition, combustion, and pressure. The design may seem simple, but the science behind it is a masterclass in mechanical and chemical engineering. Tiny metal, huge impact. Thanks for watching Origin Stories, where we uncover the extraordinary science hidden inside ordinary things. Got a question or a topic you'd like us to cover next? Leave a comment, and if we choose your idea, we'll shout you out in the next episode. Don't forget to like, subscribe, and hit that notification bell. Until next time, stay curious.